Hello everyone and welcome to part 2 of the beginner series. In this specific video we're taking a look at the next level of things, which includes the microcontrollers. So let's begin. Now if you've watched the previous video, that was intended for people that were just beginning, but this is a little bit more advanced. We're not going to go too crazy on all that stuff. Like I said earlier, if we go down here, you do have your logic, which can get you certain things, like we had the and the or. Very simple programming language. If you don't know how programming language works, then there is tons of information on the internet, but the two most basic ones that any type of programming logic requires is and or. Now, maybe fairly logical to some of you, so I'm just going to quickly run through it. But obviously an OR function is like if you have the two buttons here and you have the two buttons here and you have a light and then you have a battery like we explained. Now the only reason I'm showing you this is because it does come into play for the next part, which is the actual microcontrollers that you make. But in theory, connect logic, so we have the buttons and we have the light, and here we have the buttons and the light. So we have one OR function and one AND function. So for the AND function, if you press one, nothing happens. If you press the other one, nothing happens. But if you press both of them, then it comes on. But getting a bit of a glare from the sunlight. But anyway, now the OR function, it's either or, including both of them on. Now there are different functions like XOR and stuff, which means if the other one is not, if both are triggered, then it's actually not on. But the reason I'm bringing up these pre-made logic is because they are the fundamental building blocks of the microcontrollers. Now there are different ones that aren't necessarily in there. Likewise, there's ones that are here that are not in there. But we won't talk about that now. Now we're just going to talk about this. So this is the microcontroller editor. If I cancel out of it, all it is this last button here on the top right. So if you press this, it opens up this menu. And obviously you could type here whatever the name of the microcontroller is. You can put a description. And honestly, what I've started doing and what I'm recommending everyone does is when they first make a microcontroller, for example, we'll call this whatever, test, but you'll make it and say V1. And then you'll explain either what this does or not, but it doesn't really matter for this first one. But say you've made V2, it's always good to explain what the change is. So you've added X function. Whatever. It makes it so much easier when you're going back. But anyway, these are these two things. You could change the width and the length, and where that comes into play is here, where you add nodes. So we talked about the nodes, and you saw some of the nodes in our earlier logic, where we had the OR and the AND functions, and this is pretty much the same thing, with the addition now of composite video and audio. Now, the way that this looks here, we have it 5 wide by 3 tall, or width and length, the way they call it. And if you, well, we don't have anything to spawn, so in this case we'd have to save it, which we can do, sure. We'll just call this 454 SS test, and now it's saved. But if you cancel out of this, you can actually add it. So we find our test. Now if it's not appearing, it's because you didn't actually label it properly. I call this test V2, whereas I should have called it 454SS test V1, and that's the same name you want to give this, just to make everything easier. The name that you put here is not necessarily the name you save it as, so keep that in mind when you're trying to search for it. And likewise, now I'll delete that one, we don't need it. But if we go back to our board, now this one appears. So we can select it and put it here. And then if you press the logic, you'll see these 3 nodes appear. And now it's actually easy because if you press this select button, you can just edit it directly here. So I do recommend everyone make an empty one, just like this, with nothing on it. And then you can go and add things. The reason I'm suggesting that is because in a case where you're building a vehicle and you have limited space, it's better to put this as a placeholder than to develop your whole microcontroller here, then save it, then go back and add it. This one can be made into the other one. Like if I load up this, and notice it's a different shape. What I had there was only a 2x2. This is a 5x3. If I press add, it'll actually become the big one, even though it started off its life as one of these empty ones. So, little fun tip there. But anyway, if we go back to this, you now know that we can add the different nodes. The nodes have to be on here, like this one is not on, so it won't actually be able to work, like it's outside the microcontroller. But it's another tip is that if you're building something really large, like my ECU module that has maybe an eco mode if it's a car, or a towing mode if it's a truck, and you want to just have one microcontroller because it's easier to make updates, I actually have it such that I kind of drag and drop ones around, so that could be useful to you as well. So for this example, we'll build something, and then lastly here we have symbol. So here you can put whatever makes you happy. Obviously if it's going to be something like engine controller, it's better to put an engine, all that stuff. Yeah, and here you can label them, and that we'll get into that in a bit. That is important. Now the next thing, we were in design. Up here you obviously have your back, your update. You can make a new one, so very similar to the workbench, sorry. And then here you could upload your controllers. But now this is the other part of it. So this is the design of the layout, and this is the actual logic side. So for that demonstration, I'm actually going to add a couple more of these. We'll make one a number for fun. We'll make one of these an output and one an input. Obviously, you have no need to make it this shape with what you're trying to do here. Oh, we actually had an extra one. Okay, that's fine. We'll delete it. Anyway, with this shape, there's no need to make it a 5x3. It's going to cost more and take up more space. You're better off in this case either doing this and making it a 4x1 or making it a 2x2 and fitting all of your things on it. Like I said, if you press update, it'll update here. Keep in mind that did not save it. So you now, if you delete this, or if you spawn my other what we were just working on, if you spawn this thing, it's actually not updated. So another tip, if you're doing this, what you'll want to do, so now it's the 4x4 version, this is where you now say new size. And that you could even be smarter than me and put V1, or sorry, V2, new size, save that, V2, and then update. And now, this is technically our V1, but if you type in this, see our little happy face here, is now the V2 version. So these are the V2 versions, this is the V1 version, and I'm just going to go ahead and delete everything, go back to our happy face one. So back in editing the microcontroller now, let's add some logic. So what I always do, you see if you zoom out, you see that so middle mouse button actually moves around this board, and zoom function zooms, and left mouse button selects, and right does nothing that I'm aware of. So middle mouse button moves you around. Now these start off right in the center. It's always good to give a little bit of separation from there, just in case you go ahead and add a new node for whatever reason. It's going to be easy to find, just instead of if you have a bunch of connections and logic going everywhere, so keep that in mind. But without that, let's just start with this. So I always start, no matter how complex or simple it is, I will always line them up like this, because these are all the input ones and these are all the output ones. So this is input, even though it's labeled input, which is incorrect. Technically we'd be smarter off to say output here, And then also, I always delete these just because. This we're going to put number in. We'll call this button. And we'll call this override. And I'll explain that in a second. Just for the sake of this microcontroller and for planning, we're going to call them this. So we have our number in, we have our button, we have our override, and here we have output. And if you do drag your mouse over this, it gives you the properties and delete, but that doesn't matter for us right now. So what we're looking for is these guys. And we'll get to that in a bit. But what I do want to mention is that you have to select the node for it to say what it is. So pressing this doesn't do anything, but hovering over the node tells you. So this is a number in. It says, you see it in the dark gray, it says input next to where it says number. So this is a button off input, this is another input, and this is an output. But what these mean is that if we spawn it in here, it's their interaction with things around them. So if we add a light, for example, and we'll put a battery as well so we can plug it in, connect it right away, make sure everything works. Plug that in. Anyway, our light is dictated by the output. So you can't plug it into this, okay? And likewise, this can't be plugged into this. It needs to be on an output course because it only is a reactionary. It uses whatever you're doing to turn it on or off. You don't interact with the button and press the button, or you don't interact with the light and press the light. You only press a button to turn on the light. So the light is reactionary. It's not, you don't have an action with it. So I've plugged it in with the output. But what I want to do is have it such that we're going to have the button and the number in will turn on this, but they both have to be selected, or our override. So the way I do this is plug it in like this. So if you override it, the light turns on, and then if you press the button, but also if, let's say, you're close to the microcontroller. In that case, actually, this button would not be button, but rather we'd call this player sensor. So player sensor, and then the number is going to be another item. So if we spawn this in, we'll add ourselves a button. It'll be a toggle button. That's our override. And we'll add a player sensor. And if you don't know how that works, you could read the description here, but pretty much it scans the area and detects players, NPCs, or you. So we're going to plug this into player sensor, and then we'll plug this into toggle override, but now clearly we do need a number in. Now that number in could be this, so it could be the number of players detected by the sensor, but note, if you plug this in, you're already using this, which is the detected. So unless you want the light to turn on, if you say have 2 players only, then you could do this. And in fact, you could do, there's millions of different things. That's why I'm just giving a basic summary of this video, but let's instead set it to the clock. So we have our little clock here. Actually, no. So you do have a clock, but you could make it turn on only if it's night. And the way the clock works is the 12 o'clock position. You have to go and manually find out where each position is. So I'll actually show you how to do that. Why not? We'll plug that into this, and here we go. So one of the things that I always recommend people that are building to do is go to settings, go to general, and make sure that tooltip detail is detailed, not simple, not off. That's going to ensure that when you select this, it tells you everything about this. So you could see the time is 11:59. You could see that there's this many players here, and you could see that our button's here. So if we override, oh, we didn't plug it in. Anyway, so it gives us the time. But if we come in here, this number is a factor of day from 0 midnight to 1 midnight. So it's only going to be like a decimal point number. And that's what goes here. So even though you're reading, and we'll need a dial for this. We'll just plug this in here. We'll connect everything to the electricity. And we'll go over to our creation. Okay, so even though this is reading 1159, this is actually 0.49936. And what I always do is then you go through here. Okay, so that is night, so 18. And then if you go here, it's 0.756. So 0.75. And then if you go here, 0.25. Okay? So the easiest way would be to put a threshold. And all the threshold does is it reads whatever this is and turns it on or off. So if we were to put 0.25 and 0.75, it would only be turning the light on if it's between 0.25 and 0.75, which means it's the day. So that's exactly not, we want exactly the opposite of this. So how to do that is we use this not function. So now we're saying if our number in, or the time, is not 0.25, between 0.25 and 0.75, and we're close by to it, turn on the light. Otherwise, we override the light and it's going to stay on no matter what. So if we go over to here, we could turn that on. It works. Okay. It's not working. Why is it not working? It is not working because we didn't so our player sensor detects if we're nearby. You could change this to sphere, but I believe it's because it is working. Okay. The reason it wasn't working is because it's actually after. See, it's not 0.25 and less. It's actually above 0.259. So if we were to take this and go down, there we go, our light's on. And if we step away, it's off. So once you get into the range of that player sensor, it turns on. But if I change the time, it's actually not on anymore, unless we override it. So override, and now no matter where we are, it's going to stay on. So this is actually a very simple microcontroller, very similar to what I've done actually for the OMA Diving Academy. Because I don't want the lights on just, you know, if no one's there, it's going to cause lag to the game. Now clearly you could delete this, you don't need this anymore, because all that was doing was telling us where the number is as a factor of between 0 to 1. So there we have it. We've made a simple microcontroller. This is pretty much the steps that I take to plan anything, even the more advanced ones, like the anchor controller that I created. Look at this, winch up, winch down, toggle magall, winch input, instrument panel, all this stuff. And this is still fairly simple as far as all things are concerned, but it uses multiple things. Now, going back here, I'm going to create one from the empty. We'll grab our empty, put it here, and go to it. Now, it's empty, and we're going to go through some of my favorite things that you do have here. Maybe we should have started the video off with this, but that's okay. We have SR latch. Now, I am just going to say, doing this, you could go forever explaining all the different things you have here. There's different categories, different things, so it could be a long video. I'm not intending to do that. You can Google search what these different functions are. I'm just going to show you my favorite ones and give you an example of how to use them. So an SR latch is valuable because it actually is set and reset, and then it has an output and a not output. So how this is valuable is if you were to have an input button that is a push button. Now obviously you'd set it, but now this is going to be set until something else happens. So for example, I could have it such that it's set if the temperature reaches a certain amount. Let's say the temperature reaches 100. This is set by that temperature, and now no matter what, it's set until something resets it. So I could say don't reset it until the temperature is actually down to like maybe 60 degrees, rather than drop it once it stops less than 100, it turns off. So this actually lets you play with that, and you have these on and output functions. The not, I showed you how this works. So if it's the opposite of this, super valuable for all sorts of things. You have the and, the or, constant on signal. Now this is important because unlike me pressing the button, you could just go ahead and say, give me a constant on. Now obviously there's no reason to have a constant on and, then you just don't need this function. You just go from whatever this is. But the constant on has a ton of different applications. Pretty much any input that is required that you need it to be constantly on, you can have that and you could use it. For example, I use it in my sliding van door because when you spawn the van, I need the van to instantly put the door in the right position. So I have the on, just constantly on, telling the door return instantly to the stock position, and then you interact with it. Next we have a constant number. Now this is a green node that requires a number function. Now obviously there's all the mathematical stuff, all the adds, clamps, constant numbers, divide, equal, like all this stuff is good. Obviously I'm not going to explain basic mathematics, but what you can do is have a constant number, and even you could swap these around, saying something like, if 60 is less than my temperature, turn the fan on. So you could do that, or you could go to the greater than function and have it like this. If the temperature is greater than this, these mean the same thing. So that's using this. So the less than function, add, I have that as well as my standard go-to, and then the numerical switch box and numerical junction. Now the way these work is super important. You'll have a switch that actually switches the value. Now where you use this is very simple, say like an engine. So let's grab this, put it here, we'll remove this one. Now I will have a video after how to make a simple engine microcontroller, but let's just say for whatever, for all intents and purposes, this is my key ignition for my car. So if it's not pressed, it uses this number, which if you leave empty, it's 0, or you could also put constant number 0. Okay. And then, but if my input is turned, so if my key is turned on, I actually want this to be 0.1. And then this goes off, and then you use an addition one because, so the reason why I'm saying this is an engine microcontroller is because at idle, I wanted at least 0.1 throttle. And that's even if we're not moving, like, you know, you're sitting in your car, it's idling, there's still some throttle going on. And then this is where you'd plug in your actual throttle. So, you know, you'd grab your throttle from your seat, you'd put it here and whatever, yada yada. I'll explain that later. These are my favorite ones that I have always on the bottom for easy access, but as well you have all sorts of things here, including Lua, including like PID controllers. There's all sorts of things, blinkers, pulse. Go check them out, read the description, ask me in the comments if you don't know, or Google it. So with that, I will end this video, and then stay tuned for another video where we're going to talk in advanced microcontroller planning and building, as well as other things in this tutorial series. So thank you for watching, stay tuned for more, and happy Stormworksing.